Welcome to the GEOS 1701 Finding Your Way with Maps pre-lab material. This is the second video in the series, and in this video we're going to cover using grid references on Australian topographic maps. In the first video we covered the basic elements of location using maps, such as latitude and longitude, and simple grid systems such as the campus plan at UNSW. In this video we'll actually look at how grid references can be used on topographic maps. Here's an example of the Coffs Harbour topographic map. Not a very good scan, I'm sorry, of the map, but again, you get the idea of what the map would look like as a feature. Okay, so as we said in the first video, we looked at the use of a simple grid on the UNSW campus. And as part of using that grid system, we could actually define the location of certain features, such as the location of the biological sciences building. Well, we can put a similar grid over Australia as well. So here you can see the outline of the Australian continent and Tasmania and so forth. And again, just like we had on the UNSW campus plan, there are a series of letters up the side that define the grid and a series of numbers. They're labelled through the middle rather than across the top, that also define features on the grid there for us. Now you'll notice here that the letters run in sequence from south towards the north. So they're running in the opposite direction to our latitude was. Remember, latitude in our part of the world got bigger as we went from the equator towards the poles. Here you can see we're obviously using the grid system to run up this way from the bottom towards the top of the map. Now, there's a reason for that, because we typically want to include in this map grid all the features of the Australian continent and its island territories, and some of them are well down to the bottom that aren't shown in this particular diagram. In addition, you'll notice the numbers here run from left to right, so again, that's in the normal sequence of things. Now, running the letters this way and the numbers that way is similar to normal Cartesian geometry or coordinate geometry. So we end up with values which are positive, if you like, going up, and positive going across this way here. Now, those numbers actually, and those letters, actually all start at an origin point, and we refer to that as the false origin. And indeed, this fits into a much larger global mapping system. But for the Australian grid, that false origin, because there's no true starting point like the North Pole or the equator was for longitude and latitude, it's just an arbitrary starting point we come up with. And that false origin is way down here off the bottom of the map. But what we do is we actually measure distances on the map, not in degrees of arc, but in actual distances of kilometres and metres and so forth. So by having the origin down here, we're measuring positive values to the north and positive values to the east. And of course that means we don't have to deal with negative numbers and makes all our coordinate systems so much easier. Note also here again, just like with the campus plan, there is no letter I, and again because that gets confused with the number 1. So again, letters and numbers, and again we're actually using this now to measure distances rather than just the actual coordinate system, and we'll see how we use those distances now. So again, here's an example of a map. It's the Wollongong 1 to 100,000 map. Don't worry about the scale of it. So again, it's got the town of Wollongong, and it's been drawn at a certain scale. Well, that doesn't apply because it's a scan, and I have no idea what size screen you're watching this on. But anyway, that's the original map, and we use them in the lab classes this week. Now, on that map, just like all topographic maps, the grid lines will appear. They're pretty hard to pick up across the landmass here, but over the ocean, they're quite obvious, this little checkerboard pattern you can see here. So this crisscrossing set of lines. Now, by convenience, or by convention and for convenience, these grid lines are spaced 1 kilometre apart, because that just seems to be the appropriate distance for navigation and so forth, and without cluttering the thing up in terms of showing the features. We could put them closer together, we could put them further apart, but 1 kilometre is appropriate, and we'll see how we interpolate within that grid in a moment. So as I said, here's the town of Wollongong, and here's the bottom corner of the map sheet here, Port Kembla Harbour and so forth. Let's zoom in on this bit in the next slide and see how we can look at a bit more information on these grid lines. So here we are zoomed in on the bottom right hand corner, and again here's the town of Wollongong here is shown there, and you can see it's quite obvious the grid lines now. These the pale blue background, but these blue lines here are our grid lines. And as I said, they're most obvious over the ocean. You can still see them, they run across the land, but they're not quite so obvious. Now these lines, as we said, are 1 kilometre apart, so each little cell here is 1 square kilometre. 1 kilometre this way, 1 kilometre that way. Now, what we should appreciate then is that these grid lines also have numbers. So running up the side, you can see each of the grid lines are numbered. So the little blue line has a little blue number that's attached to it. So the numbers, as we said, just like the letters, get bigger as we go from the bottom towards the top. So as we're moving from the south to the north, the numbers get bigger. So you can see here 81, 82, 83, etc. Ignore the little 61 in front of the 85. We'll talk about that little value later. So let's just deal with the big whole numbers. Now, as you can see, they go up in units of 1, and these are 1 kilometre apart. So these are literally measuring 1 kilometre distance as we go up the side of the map. And they're measuring distances north. So quite creatively, we give that the name of northings. So northings are just literally distances north. North of what? North of some false origin of the Australian map grid. So the northing lines themselves run east-west. This is where it gets a bit confusing because people go, oh, northings, just think northings measure distances north. But of course, the lines that make up the northings are actually running east-west. But the main thing is northings measure distances north. All right, across the bottom, again, as we can see, there are little blue numbers attached to each of these vertical grid lines. And of course, they're numbered as well. They get bigger from left to right. Again, ignore the 3 in front of the 10 or the 15. But we can see it goes 10, 11, 12, 13, 14, 15, etc. And they're getting bigger towards the east. And again, these distances are 1 kilometre apart. And we're literally measuring distances east from the false origin of this part of the Australian map grid. So again, we call them the creative name of eastings. So northings measure distances north, eastings measure distances east. Again, if we embellish the grid a bit with some darker lines here, again you can see that these things again are lines that run north-south, but again we're measuring between those lines to measure our distances east. Okay, so that's on a Wollongong 1 to 100,000 map. What about other maps at different scales? Because maps are made at different scales. Here's a larger scale map. Again, we'll cover what that means in another class. But again, this is a 1 to 25,000 map, and it's for a subset of the Wollongong area. And so this is an area just in the northern suburbs of Wollongong. The town of Wollongong is just down off the bottom of this particular map here. So they're the same grid lines. You can see there are grid lines here over the ocean. And again, they are 1 kilometre apart. So on all maps, we're going to show these things 1 kilometre apart. As I said, is our best compromise for detail and ease of use. So this is 1 kilometre here. Now this map is at a different scale. It's showing more information. So those grid lines appear a bit bigger. Of course, they appear different to the way I've zoomed in the size of the scan as well. But on the original paper maps, these grid lines appear much further apart because of the nature of the map scale. But in reality, they're 1 kilometre apart, just like they are on the previous map. Now that scale is a function of the fact that you're just zooming in on part of the landscape. So that map we're looking at now, part of the Bulli map, as you can see here, is a subset of the overall Wollongong map sheet. Here's the town of Wollongong, and we're just in the northern suburbs up here. This area here is actually part of the world we'll go to on our field trip. So we're going to study this a little bit more, and we'll actually go down this road here, which is the Bulli Pass, as part of our field trip. So let's look at the grids, using the grid on that Wollongong map sheet, that Bulli map sheet. And we're going to zoom in here in the area just to the south, which is just this part in here. So let's zoom in on this bit near an area called Bulli Harbour and Bulli Point, so that area in there. So here we go, we've zoomed into that little bit, and you can see Bulli Harbour is clearly labelled. And again, it's very obvious now to see those grid lines. Remember, they're 1 kilometre apart. And again, because we've zoomed in and just truncated the map, we don't see the margins. So I've written them on for you. Now note the northings again would go northing 98 is below this, then northing 99. This should be northing 100, but we actually don't include that on the map here. It's labelled here. Sometimes they are labelled on the map as well as down the side. But again, we just reset it to 0, and we'll talk about how we deal with that a little bit later. So those numbers get bigger. from 99 to 100 if you like. We're going to call it just 0, 0 for the moment. Now the eastings get bigger again from left to right as we go from west to east. So easting 0, 9 is this line here, and easting 10 is this line here. Okay, so what we want to do is actually give a location or an area reference for Bulli Harbour, this feature. Now for big features like that consume an entire grid cell like this is an entire grid square here, then it's convenient just to refer to that entire grid cell area or the area reference for that entire part of the grid. So if we look at that, here's how we would actually give the reference for that particular grid cell. Just like everything, we refer to the origin of that grid square. So we're going to call this an area reference, and we need to find that intersection point, and as an area reference, that will define this entire grid square, just like that there. So again, the origin of that is where the line 09 easting meets the line 99 northing. So we give the easting value, this easting value first, that's like our x coordinate, and then we give the northing value our y coordinate second. So as an area reference, we get 09 space in here 99. So 09, 99. And that becomes the area reference that refers to that entire grid square, which is where Bulli Harbour is. Okay, that seems fine, but what about where you've got smaller features that, you don't want to just do things to the nearest square kilometre. You might want to define a building. So here's just a map that we have that was just a cartoon map we've made up. And again, it's got grid squares on it. You can see here's an easting 54 and 55, an easting 18, a northing 18 and a northing 19. A road, a creek, a lane, and this square here is a house or a building. So how would you define the actual location of that building? Well, we can interpolate this grid. It's not that hard to break it up into tenths and actually give the nearest tenth of that grid square, and that gives us a location to the nearest 100 metres this way and the nearest 100 metres that way. So that means we actually end up with a much finer resolution on the actual use of the grid system. So let's see again how we would do that. You can see here that if we look at here, giving the easting first again, remember, we're 2/10 of the way between 54 and 55. So 2/10 of the distance would be 54.2, but we ignore the decimal place just to make life easy. And so we just give that as the grid reference, not an area reference, but a grid reference of 542. Again, if we look at it going up on the northing, we're 3/10 of the way here from 18 to 19. So that's 18.3, but again, we ignore the decimal and just call that 183. We put both those numbers, again, we put the easting first and then the northing, and we end up with 542 space 183. And that's actually the grid reference. Now that gives us a location now, which is now interpolated down to the nearest 100 metres. So rather than this little sort of cartoon example, let's look at a real example on the map. So again, here's the rule. We'll go through this town on our field trip. And again, here's some the easting 09, the easting 10, the northing 00, and the northing 01 here. And again, we might be interested in saying to someone, what's the location of this surf club at Thurul Beach? So basically there, we need to interpolate between this 09 and 010 and interpolate between the 00 and the 01. So again, looking at that, we can see we're 3/10 of the way between 09 and 10. So we'll call that 093. And we're 9/10 of the way up here between 00 and 01. So that's 009. Now you can literally measure these distances on your ruler, and so you can be quite accurate. So don't just try and guess it. You should actually get a ruler out and measure those distances on the map. And we'll have some practice of that in the lab classes. So the grid reference in this case is 093, always give the easting first, and then 009. And remember, put a space between the two. Now, one of the things that's different in your lifetimes versus students that might have done a course like this 30 years ago is that we don't rely upon paper maps so much. We rely upon maps that are derived, or images and mapping systems derived from orbiting satellites around the Earth. And so basically what we've got here is a range of global mapping systems using global positioning system satellites. Now there's a variety of satellites in use, but again, these satellites orbit the Earth and they're a function of the actual Earth's gravity, and so they're geocentric in terms of what the actual orbital function is like. That's different to geostationary, by the way. Geocentric is something which essentially, again, is a function of how this satellite relates to the Earth's gravity field. So if you like, it's sort of like the locations now, like according to the centre of the Earth, rather than actual the surface of the Earth. So most people are used to using GPSs on their phone and in their car and so forth. So what we had to do is previously we had a map grid where we actually broke the thing up using, again, a series of letters and numbers. And that was based upon some false origin we put down here off the southwest coast of West Australia. So we previously had a map grid called the Australian map grid. With the GPS system, we've had to replace that because we've actually had to modify the whole way we've actually set the map up. And that's because we're now using satellites which aren't fixed relative to a false origin, but are fixed really to how they orbit the Earth. So we replaced the Australian map grid with the map grid of Australia. Yeah, they're pretty confusing, I know, but they are different things. This is the new guy. This one here, the Australian map grid, is the old guy. Why that's important is because old maps are different now to new maps. And in particular, what happened is on the new maps, to go to the map grid of Australia, we've had to change the eastings by about 105 metres and the northings by 190 metres. So there's a bit of a mismatch between our old maps and our new maps. Okay, so there's even another version of geocentric datum. So the geocentric datum of Australia is being changed again. There's information at the website that's shown there. But there's going to actually be another update again, which won't affect probably the way you're using your phones and that, but actually makes them slightly more compatible to using this geocentric datum, just so that when your sat-nav says to turn left, there really is somewhere to turn left into. All right, careful though if you are navigating with a GPS system, because they're not infallible. And again, this is a bit old. This is a 2012 news story, so it's a few years old now. But most people don't appreciate that when you get outside of many major towns, there's not as many GPS signals to pick up on. And so quite often it just puts people in the wrong place. Just be aware that in the cities, yes, they're probably meter accuracy, but they're probably tens of meters accuracy when you get outside the city. All right, that's the end of this pre-lab. Again, it's given us some idea of how to do proper grid references and also area references. Again, there's some notes and exercises on Moodle, so look at that before the next lab class. Okay, thanks for viewing, people. Bye for now.